Redox day 9, do now. How do we determine the electrochemical voltaic cell? So, what we have here, guys, I'm sure you've seen the word before, volts, right? Volts is from the Italian scientist Alessandro Volta. So he helped develop the battery. All right, that's why it's named volts. All right, so let's see what's going on here to do now. Fe is going from +1 to +4. Now we learned that when the number goes up, what does that represent? Well, correct, that represents oxidation. So in this case, from the word oil rig, we lose, in this case, from 1 to 4, 4 minus 1 is 3 electrons. Magnesium is going from 2 to 0. That number is going down, reduction, gain, 2 electrons. Okay, so oxidation, we said was Fe. They want the half reaction. So this is writing half of the reaction. Fe plus 1, or plus, doesn't matter. Arrow to Fe plus 4. And we're simply going to add the 3 electrons. Remember, guys, where the electrons go? Well, they go on the side that has a more positive charge. So what's more positive, 1 or 4? Well, 4 is more positive, so we had the 3 electrons there. Don't forget the negative sign above the E. One year in the Regions, they really hammered a lot of kids by it. If you just wrote E, you were wrong. Okay, reduction. So magnesium going from Mg plus 2 to, right, Mg plus 2 to Mg0, or just Mg, same thing. I'll put a 0 so it's for illustration purposes. So from 2 to 0, that's 2 electrons. So again, who has the more positive charge? Well, plus 2. So we're going to simply add 2 electrons there. Now, if you want to balance the equation, we have Fe plus Mg plus 2 going to Fe plus 4 plus Mg. Well, again, 1 to 4 is how many electrons? Well, that's 3 electrons. 2 to 0 is 2 electrons. What's the least common multiple of 2 and 3? Well, correct. That equals 6. So, the number you multiply by is the number that goes in front of the element. Well, 3 times what gives me 6? 3 times 2. So 2 was attached to this guys right here, these guys right here, Fe. So Fe gets a 2 as a coefficient. 2 times what gives me 6? Well, 2 times 3. That's attached to who? That's attached to Mg. So 3 here, 3 here. Balance equation. Okay, let's proceed. Okay. So this is just a quick illustration of what happens here. This guy over here is called the salt bridge K03. And then electrons flow. All right, here's your salt bridge, right here. The electrons flow from anode to cathode. Now, if you notice, this piece of metal, iron Fe, is losing ions here. Okay, and electrons are flowing this way, left to right. Because they always go from negative to positive, right? Electrons are negative charge, they go to the positive charge. So what's happening is the metal is decreasing here, but the metal is going to start increasing over here. And we'll learn this is how you do, that's why batteries die, because eventually all the electrons leave from one side and go to the other side. All right, let's get to that in a moment. All right, let's go over here. So electrochemical cell, all right? So, all right. So now, very simple over here, okay? Let's look over here. Oh, no. Okay. So, there are 2 ways to do this, guys, right? If you go to table J in your periodic, on your reference tables, you'll notice that Zn is higher than Cu, okay? Let me see if I can find it for you over here, actually. Yes, here it is. Okay, here is Zn. Here's Zn, and here's Cu. So the element higher, we say is anox. The element lower is red cat, okay? So, like, what does that mean, anox, red cat? Well, very simple. Let's go back over here. Okay. So, anox is an acronym for anode, There's two sides of a battery. There's the anode, and then red cat is the other side is the cathode. Okay, cathode. Ox, well, you should know what ox stands for. That's abbreviated for oxidation. So if you memorize the words anox and red cat, you pretty much know all the answers. Red stands for reduction. So what does that mean? Well, oxidation occurs at the anode. Okay? That is your negative charge end. That's your negative end of the battery. Reduction, red cat, reduction occurs at the cathode. That's your positive end of the battery. Okay, that's why if you notice over here it's positive and over here is negative. Okay? Now, let's read what it says here. Electrochemical cell. It's a spontaneous reaction, right? What does spontaneous mean? Out of nowhere. Where a chemical reaction produces electricity. Chemical to electrical energy. Very important. Just so you know the term, whenever you see the word equilibrium in a redox reaction, it means it's 0 volts. The battery's dead. So electrons flow over the wire. Here's your wire, right there. Okay. From anox or anode to cathode. Okay. Electron flow. So it's going to go from Zn solid to Cu. These are solid metals here. So that's why it goes from Zn to Cu. Okay. Or you could just write anode to cathode. It's always correct. Okay. Now let's go over the salt bridge here. Okay. There. Okay, so again, if I look this up on table J, Cu is actually higher than Ag. So this side's anox, negative. This side's red cat, positive. Now, don't always think the left side's anox, negative, right side red cat, positive. They can switch the metals and it's the opposite. Okay. Now, this is talking about two purposes of the salt bridge. Okay, here is your salt bridge, guys, right there. Okay, you need salt, ions. Ion flow, okay, in batteries. Now, normal batteries that we use usually has a very, very strong conductor of electricity, acids. Acids are very, right, the stronger the acid, the more ions released, the better the conductivity. So we use mostly, like, you know, if you look at the, the batteries we use, they all have acids in them. Acids are great conductors of electricity. Okay, so let's go back to over here. Two purposes of salt bridge. It permits the migration of ions. Now, ions are the charged particles, right? So where are they? Here they are. Cu plus 2, Au, Ag plus, like that. So, so it permits ions. Ions go in both directions, by the way, back and forth. Now, if you notice, this is in one container or one beaker. This is in another beaker. So what don't you want these two solutions to do? Let's think a second. Okay, that's right. We don't want to allow them to mix, so it prevents the mixing of the two solutions. Because if these two solutions mix together, the battery's dead. Okay? All right. So like we said before, table J. The element is higher in table J. All right? The element is higher in table J is anox negative, while the lower element is red cat positive. So if you look at the two elements here, BaCr. Barium, here's barium right here. Chromium's right here. Because barium's higher on table J, that element undergoes oxidation, and it's the anode. Because this element's lower, that's reduction cathode. Okay, pretty easy, right? So let's look at this chart over here, this little question chart over here, okay? First thing we gotta do is label which side's anox, which side's cathode. Anox, which side's red cat. Well, we go to table J. Let's go back to table J, guys. All right. We have the two elements we saw was Zn and Cu. Well, I think we just did that, did we not? Yeah. Here's Zn, here's Cu. Zn is higher. If it's higher, it's anox negative. The element is lower, which is Cu, is red cat positive. Okay, so let's label that side right now. What is the direction of electron flow of the wire? Well, electrons flow from anode to cathode. So it's going to go from, so you can say either anode to cathode, or you can just simply say Zn solid to Cu solid. Goes over the wire, guys. All right? What is the direction of ion flow? Well, what do we always say? Ions flow one way or both ways? Well, ions flow both directions. So they go both ways. Or you can say, right, because these are your two ions here. Zn plus 2. Let's put a double arrow. By the way, it's aqueous, because this is in water. It's a solid water, right? And Cu plus 2. Aqueous. Which is the anode? Well, you know the anode. Right here, it says An. And that's the same size as Zn, so Zn. Which is the cathode? Well, here's a cathode. And that's the metal, Cu. Which electrode's positive? Well, see, guys, this is why if you know which side anox, which side is right K, you know the answers. Positive is right here. It says right there. That is the cathode. Or Cu. Which electrode is negative? Well, negative charge right here. That's the anode. Or Zn. Why happens to mass is Zn? Well, because Zn undergoes oxidation from the word oil rig. We learned oxidation is loss of electrons. So, guys, if you lose electrons, what do you think is going to happen to your mass? Well, it's going to decrease. Copper. Copper's on the right side. Copper undergoes reduction. Reduction is gain of electrons. What's going to happen to your mass? Well, it's going to go up. Right, to half reaction oxidation. Well, Zn is going from, here's Zn, to Zn plus 2. Where you put the two electrons always, inside that's what? More positive, so it goes right here, 2e negative. This is react spontaneous or non-spontaneous? Well, this is a, whenever you see a salt bridge there, spontaneous reaction. Okay.